G'day guys, welcome to the first video in a set regarding how to do a student experiment. We're going to go through the pieces in individual videos. This one is going to focus on giving you an outline of the whole methodology, as well as delving into the ISMG marking guide and looking at the specific language that you need to be aware of. So you'll have a cover sheet something like this. And the very first thing of note is that your length is 1500 to 2000 words. Normally we give you a word limit. In this case we have a word range. That means you must stay inside that word range. If you go over it, it will cost you marks on the communication criteria down the track. So that is not a, oh yeah, I've got 10% over that. That is your limit, 2000 words, and everything is part of that. So do be aware of those. Note, it is group work within individual report. You must submit your own report. And typical resources that we can use. So the context of this is that we have done some practice in class. So here are the four for physics. We can see we have verified acceleration due to gravity. We've confirmed Newton's force equation. We've examined the relationship between angle, distance, and of projectiles. And we've examined the relationship between perpendicular and parallel components on an inclined plane. Now, your context may look different depending on whether you are doing biology or chemistry. However, you would have some practice that you've already done. So the task, and we have it here in the box below, is that we need to modify. Now, modify comes under three words. We have refine, we have extend, and we have redirect. We will look at what each of those words mean in the video about modification. So if you want questions about that, go look at that one. But you need to do some change to an experiment and relate it to your own hypothesis or question. You can use one of three things: a prac we've done in class, so one of the four from up here for physics, a related simulation, or another prac related to Unit 1. So the thing is, though, all of these have to be the basis of a methodology. So let's start with the hardest, another prac related to Unit 1. Now, just as a side note, doing a harder process doesn't mean you get more marks. It does not really benefit you to go and do something that is much harder than what other people are doing, solely to try to show off. There's no arms race going on here, at least as of yet. So don't think, oh, that's the hardest, I want an A, that's the one I've got to do. You can get an A with the easiest one, just as easy as you could with an A. In fact, it's probably easier to get an A with the easy one than just get an A with the hardest one. So what this another practical means is that you may find a prac online, or you may find another prac in the syllabus that we haven't done, one of the suggested pracs, and use that as the basis for modifying. Note, I said that has to be the basis. So not only do you have to go and look up this prac, understand what it would do, think about the sort of data you would get from it, you then need to modify it. Okay, so that's why that's the hardest, because there's a lot of work to do on your own before you even get to the actual experiment. The next one is related simulation. Now, related simulation in this case means it's something that runs on a computer. The problem is, and this is a difficulty that a lot of us are finding as teachers, is that your simulation must have error built into it. So if I take a game like Angry Birds, if I pull back the projectile a set distance at a set angle, it'll always do the same path. That is not a simulation. Okay, that is basic computer programming. You give it the initial conditions, it does the same thing again and again and again. In a simulation, if I have the same pull distance and the same angle, it won't always end up in the same place. It'll be pretty close, but there'll always be some slight variance, and that is what is needed if you're going to use a simulation for the basis of your experiment. There are a few out there. I've seen some for some projectile motion stuff, and I imagine that biology ones would have one as well, chemistry ones might have some as well, but this is very new, so people won't have purposely made any to match the syllabus really as of yet. So if you're going to use a simulation, check it with your teacher, but make sure the very first question is, does it have error? If it doesn't have error, it's useless to you. Move on. It's not any good. The last one is a prac performed in class, and we have the four here that I've listed. You will have your own for both biology and chemistry. So, the student experiment is marked on four criteria. These are your research and planning, your analysis of evidence, and your interpretation and evaluation, and finally a communication mark that looks over the entire thing, in total worth 20 marks. But you can see though these first three are weighted 6 out of 20 each, while this last one is only weighted 2 out of 20 each. Let's continue on. Now we have here a list of steps that must be completed for the task. I'd recommend going through these and ticking them off as you move through it. Identify an experiment, develop a research question. Now you can read those there for yourself in your own time, but if you can't sit there and tick off directly, yes, I have done that, or if you go to the teacher and go, so have I done this, miss, have I done this thing, that's really your first step. If you don't know what to do, go back to this and check, please. Some checkpoints, authentication strategies, and here is scaffolding. Now there should be one of these for both biology, chemistry, and there is one for physics, as we can see. And again, we have a similar sort of idea about what needs to go in the scientific report: research question, rationale, etc., etc. We have here an example here, and we can see how it is taken a prac that's previously been done, the parallel component of an object down an inclined plane at various angles, and it's asked a different research question, and then it's gone through it. Now this research question is useful, and we'll see how it evolves through this text. This last one, what is the relationship between the angle of inclination and the magnitude of the frictional force for a given rectangular-based wooden object on a given wooden surface? Now, we'll come back to that in a minute, and we'll especially revisit this in the modification video, because this specificity of the wording here is really important. Okay, but whatever one we give you as a scaffold, you can't do that for your student experiment. Okay, so let's have a look into the ISMG. So these are the marking sheets that we're going to be using. You'll see that here's the first. If you get enough, all the ticks in here, you get a 6. If you get most of the ticks in here, you get a 5. If you get all the ticks in here, you get a 4. Most of the ticks in here, you get a 3. If you get a couple of ticks in here and one tick in here, you get a 5. Note there's no 5.5, there's no 4.5. It's either you get 5 or you get 6. You get 3 or you get 4. So do be aware of that. And then 1s and 2s down the bottom. Now, I'm going to go through some of this language in this and how to read these, because it is going to be relatively new, and it will be important for us to understand what these words mean. Each of these characteristics is based off of a description here at the top, and then some evidence for it. So we can see here, informed application of understanding of the topic to modify experimental methodologies demonstrated by, and it's this word demonstrated that we really care about. I will be able to say that your experiment has demonstrated an informed application of understanding of the topic if I can see these two things. If I can see those two things, 2 ticks, bang, you've got the top criteria. Same for the next one. I will be able to see you do effective and efficient investigation if I see those 3 things. So these ones here with the dash, that's what we're looking for. This word demonstrated will always clue you in on what we're looking for. So firstly, first part of this is that a considered rationale for the experiment. So considered in this case means that you've provided careful thought with attention to detail. So if you're thoroughly going through every part of the variables that could be related to your experiment and explaining how you're going to control them, how you're going to measure certain things, what important things you have to take note of, that would be a considered rationale. The next one here is justified modifications. Justified, remember, means to back up with evidence, so you need to give a reason for making a decision. And sometimes these reasons could be just a simple sentence, sometimes they may be a little bit more complex, it depends on what decision you're making. For example, it could be that you say, well, the methodology that was used to gather data in the first experiment was too error prone. Maybe you're using some human timing reactions, and so we're going to use something like a light gate or more repetitious, so that we get the average of 50 trials instead of the average of 10 trials, something like that, where you remove some of the error. But again, that there we're giving the evidence for why we're doing it, we're justifying it. If we have a look at the second topic here, effective and efficient investigation of phenomena demonstrated by a specific and relevant research question. Specific in this case means that it's clearly defined and identified. The conditions are detailed, which is what happens up here. Here we can see that it's the magnitude of the frictional force for a given rectangular based wooden object. The fact that it says it's rectangular based, that's specificity. Is it different if it's a circle based? Is it different if it's a triangle based? Is it different if it's a square based? What about a trapezoid? We don't know, we're just testing rectangles. Wooden object. Is a wooden object different from a plastic object? What about a metal object? We don't know because we've specified that we're just testing wooden objects. Given wooden surface. Okay, why we're using a wooden surface? Well, that would be part of the theory about why it matters what surface it's on. But again, we're saying that it's on a wooden surface, not a metal surface, not a laminated surface, not a plastic surface. Okay, we've said it's specifically wooden. And another word in here says the magnitude of the frictional force. We're just asking about, well, how big is it? And these sort of key things in here inside the research question, that is what we mean by it's specific. Okay, and so that's a really important thing to consider. If you write your research question, the very first thing after it should be, well, how can I make this more specific? Relevant in this case that it's connected to the subject matter, and so it needs to link specifically to your research question in terms of the specificity, and we'll see that as well with the next word here. So we have a considered methodology that enables the collection of sufficient relevant data. If your data doesn't connect to your research question, it's not relevant. Okay, only measure and record the things that are relevant to it. Or, to be more precise, only present the information in your final report that is relevant to your research question. You might measure a bit more and then realize, nah, didn't need that, and cut it back a bit. That's good science. Okay, so that way you're presenting just the stuff that matters for your report. Considered, again, we saw that word earlier. Sufficient is an important word we'll see a little bit later on, but sufficient in this case means you've done enough. And finally, considered management of risks and ethical environmental issues. Again, considered in this case is that you're giving attention to detail. Now the 3s and the 4s mostly are sort of your standards, in that as long as you're doing a basic amount, it's going to be fine. There are 2 words here I want to look at though. A reasonable rationale. So that means the rationale is appropriate and it makes sense with the theory that you've learnt in class. If you were to talk about friction, for example, I would be looking at things like the effect of the normal force, a coefficient of friction, anything like that to do actually with the theory. If you're in biology and talking about enzymes, you probably don't need to go in much detail about genetics because it may not be relevant to your actual research question, and so it wouldn't be a reasonable rationale. The second one there, a feasible modifications to the methodology. Feasible just means you can achieve it. So if you turn around and say, well, I'm going to use a light gate to measure how fast something is going, great. You wouldn't turn around and say, oh, I'm going to use a robot to measure how fast it's going, because I don't have a speed sensing robot for you to use. So it has to be feasible achievement. So those are the ones for our research and planning criteria. Let's head down into analysis of evidence. Again, analysis is another 6-point criteria. This first point though, we see here it doesn't have any dash points after it, neither does this third one here, but it does have the word demonstrated by, and so that tells you what you have to do in order to achieve this standard. To get appropriate application, you need to demonstrate correct and relevant processing of data. Appropriate in this case means that it fits the purpose, that it's suitable, okay? But to show me that you have fit the purpose, that you've done something suitable, you've done correct. That means you did your method right, you did your analysis correctly, and you used relevant processing. We saw that relevant before. It means it's connected to the subject matter. I'm not going to get you to do 2-factor ANOVA analysis of your experimental method when linear regression is probably going to be sufficient. You would choose to go, oh, well, if I need a error in my gradient, I could choose to do a linear regression model, or I could choose to use a 3-line gradient. Again, it's up to you in order to get that appropriateness, that it's correct, that you've done the right thing. Next one there, systematic and effective analysis of experimental evidence about the topic demonstrated by, and we've got 2 criteria there. So thorough identification of relevant trends, patterns or relationships. Second one, thorough and appropriate identification of the uncertainty and limitations of evidence. So in this case, remember, identification means you're providing statements, but thorough means to do it very completely and you find all the relevant trends and relationships in your data. For example, it may be that you identify that as your X variable gets bigger, your Y variable, the error got larger, or vice versa. These would be trends and relationships, not just to say, oh yeah, there's a linear relationship, but how tight is the linear relationship? Does it have a good correlation, or is the error fairly large? Is the error consistent, or does it increase or decrease as you go across your variable? So it's about delving into depth on that to be thorough. Last one there, effective and efficient investigation of phenomena associated with the topic, demonstrated by the collection of sufficient and relevant raw data. Sufficient, you've got enough raw data; relevant, that the data actually matters for your research question, okay, especially in what you present to us. Finally, in the 3-4 line, the only one that's really important is this word adequate. Adequate just means you've done enough, but there was plenty more that you could have done. So, you've done enough to pass, but really you could have got a lot deeper. Most of the rest of there is just this with some words removed. Down onto the third criteria, interpretation and evaluation. Again, another 6-pointer. Our first one here, we have insightful interpretation of experimental evidence about the topic demonstrated by justified conclusions linked to the research question. Insightful in this case means that you're showing understanding of your results by looking at all the data, that you're making decisions by looking at everything as a whole, not just a couple of individual pieces. The justified conclusions, again, justified meaning that you're providing evidence, but make sure here it says linked to the research question, that you actually link it back to the research question. It's a really easy mistake people can make where they don't link back to their research question. Next one there, critical evaluation of processes about the topic, demonstrated by justified discussion of the reliability and validity of the experimental process. So justified, again, meaning you're giving reasons, but reliability is an important word. Reliability means that if you do the experiment and you give me your method and then I go do the experiment with the same gear and the same setup, will I get results that are pretty similar to yours? Not exact, because obviously there's a little bit of error involved, but if you do something where you get 5 values that equal 5 and then the next one equals 10, well, then there's something there that's a little bit weird in terms of reliability. It also means that if you are looking at your data, and sorry, this should go back into analysis, but if you have you're gathering data and you have 5 bits of data that say, oh yeah, it's about equal to 5, and then your next one suddenly is equal to 20, well, that tells you that there's something weird that's happened there, and you can discard your data. And we'll talk about that a little bit when we look at designing your methodology and your analysis, because there's a lot of experiment calculations you can do to speed up your ability to process. Next one is that word validity there. Now, validity means that did your method actually measure what you thought it did? Did you actually get results of about one variable as it relates to another variable? And this is where your theory comes into play quite extensively, because it may be that there is something you didn't consider that is also affecting it. So you need to sort of sit down and really ponder over the results and what was happening, about whether or not something else may have been causing the effect that you're trying to measure, and that your 2 variables aren't actually linked. But there might be a confounding effect going on. Finally, suggest improvements and extensions to the experiment. That just means either fix something or make it go further, which are logically derived from the analysis of evidence. Logically derived is a really important one there. Your suggestion has to come from what can be seen or inferred in your results. If you infer it, you need to explain the inference. For example, if I was to say that the range of error on my results gets larger and larger as I go across to the y-axis, that tells me that my equipment is really not suitable for the method, or maybe my range of range that I'm looking at is too wide for the equipment that I'm using, and perhaps I need to use something that's a bit more fine-tuned for those larger or smaller values. Okay, and on to our last criteria, communication. Communication is only a 2-pointer, which you might go, oh sweet, it's only 2 points. But to me, it seems very easy to lose 1 mark in communication and end up with just 1 out of 2, while getting to that 1 mark is pretty easy to do. So let's have a look at the first one. Effective communication, or the only one, sorry, effective communication of understanding of and experimental findings, arguments and conclusions about the topic, demonstrated by 3 things we're looking for. Fluent and concise use of scientific language and representations. Fluent means that you are writing well with eloquence, you have good grammar, your paragraph structures will help with this when you write that essay, and it also means that you're actually using the words and terminology appropriately. If you are not using precise scientific type knowledge words in your responses, you are not writing fluently. The second word in that description, concise, means that you need to give me good depth about the topic, but you're not rambling and you're not giving me repetitious writing. Complex write that essay sentence structures will help, but you have to stick under the word limit while achieving all of the rest above. Note that while the word limit says 1500 to 2000, if you're under 1500 and you did all the rest, then I can't see why you'd be getting penalised for it. The 2000 upper limit, the 1500 minimum is sort of more of a guide to say, well, if you're not at 1500, you probably haven't achieved the A standard. But 2000 is your hard upper limit, so be aware of that. Appropriate use of genre conventions, you write it like a report. You use a nice title page, you use headings, you put your name in the right place, you put your teacher's name, you put the due date, all those little things, just to make it look nice and neat and formal. And finally, acknowledgement of sources of information through appropriate use of referencing conventions. This one's a tricky one because referencing is really tedious to do, especially if you're not aware of how to do it to begin with. So there is a fantastic website I like to use. QT does it, called CiteWrite, CiteWrite, and I'll put a link in the description down below. But this video can, this website can provide examples of many different referencing styles and how to reference pretty much anything that you'll ever find online or in a library. Whether you want to use APA, which is the one I personally prefer to use because that's the one I generally used for my education degree, you may want to use Harvard, you may want to use legal, it's entirely up to you. I know Microsoft Word does have a referencing function inside of it. I've personally never used it, but it may be worthwhile to learn how to use that in the immediacy so that when you are writing your report, you're able to put in your references straight away and it will pre-do a lot of that stuff at the end for you. Alright, so this has covered a couple of things. Firstly, we've covered the outline of what you need to do for assessment, and secondly, we've gone through the ISMGs and looked at some of those keywords that you will need to refer to. Remember, all these keywords are also defined in the syllabus. You have access to that. It is not a restricted document. If you want to look at the biology, chemistry, physics syllabus, we can either give you a PDF copy, you can come and ask for a hard copy and sit down and have a read through it. It is like 120 pages or so long, so we're not going to print one off for you, but you're happy to print one off yourself if you'd like. But you can go and look up any of these words and see exactly what we are using in order to check how you're going. Okay, this is not hidden knowledge. Next video we'll start looking at what modification actually means, and then we'll delve into methodology and rationale so that you can get ready into your experiment. Thanks for listening. Have a good night.